in this prototype. We want to write a prototype for the runtime of a game of Connect 4 that transforms user input given an n-dimensional board with m players stopping the game if one player wins. This is our opportunity to see if this prototyping approach actually works. So we're going to revisit code that we've written previously, and we're going to see if we actually can put that code together. And one of the nice things about writing this in small incremental prototypes is integrating them together can be a little bit clumsy, but if we know exactly where we've hard-coded these, we can at least just double-check that this works. So this is our core simulation. Then let's see if we can grab our win condition, which we didn't finish, but largely, the win condition doesn't need to be finished to prove that we can bring these pieces together. So I might even leave this as is. Here, this gives us each time somebody won. So these are the wins that existed, given the state of the board at some point in time. And here we'd say if wins, then we break. And we need to pass this the players, which we specified up there. Very good. Let's move some of this information around. Actually make this starting to look like a real Python script with an if name equals main. And one of the reasons why we might choose to do that is to start giving people visual indication of what parts of this are part of our framework and what parts of this are part of your script that you write. We need a chain here. We probably need sliding window view as well. Sliding window view. And I believe we can improve our ability to write this and to make this work. And I guess in those sequences of moves, nobody won. So just to make sure that this actually does something, why don't we use some random data? And you can see I know these imports off the top of my head because generation with random data is something that we do all the time. It is a great tool for very rapidly creating really simple use cases to prototype. Now, here, what I'm going to do is I'm going to say random.choice of 7, size equals 100. But I'm going to actually try and preserve the original structure. I don't know how swapping out that list with an NumPy and D-array will affect the downstream code. So now I just want to lock in whether this works or not. So I'm just going to leave this as a list, and then later I'll come back and kind of put it as an NumPy and D-array. Now here, we're going to print out each state. And I think here we yielded the board at each stage. That's good. That's good. Let's see why this thing breaks. I guess we must have somebody winning. Well, okay, so that's the first state. Very good. And it breaks after that immediately. Well, let's look at what the wins are. Oh, because we decided not to choose these. So we have to then evaluate these wins. So we have to do win.all for W in this. And we'd have to say if any of these were wins. And then here we can print out the board. So I think this should just kind of play the game randomly. And you can see the game gets played until somebody won using our winning condition. There we go. And the last piece we might do is, before we present this to somebody, we might then take a deep breath, a deep sigh. We actually managed to prove that this is possible to do. There's still quite a bit of work to actually make this ready for production, but this is where we might take a step back, let our brain rest for a bit, and then do something really simple like visualize this. Give us the ability to say something like, join each row for the row in the board, so that when we pass this off to an analytical user or a business user, that user doesn't have to see, the ugly state of the board. They can see something that's a little bit nicer. And here we might do something like this. Each cell for the cell in the row. And we might do something, this if the cell value happens to be, make this print a little nicer if the cell value is our null byte. Something like that. And there you go. And you can kind of show this to them, and they're like, oh yeah, it looks like a game of Connect 4. And again, something like this. And they can say, oh, that's a game of Connect 4. You managed to solve the problem. But you can see we did that at the end once we have proven that everything else is working. And they'll say, is this ready to go? And you'll say, well, I didn't do all the win conditions, but I know the other win conditions are just extensions of the code that I've already written. They say, oh, how about the data input format? And you say, well, you know what? We've proven this works. why don't you come back to me when you're 100% sure what the data import format is going to look like, and then I'll clean up my code for that. But what we can see here is that live coding itself, not a very valuable skill in the real world. It's a gimmick. But prototyping and working efficiently and iteratively, an incredibly useful skill, and there are actually direct, deliberate, learnable things that I hope that we've shared with you today. If you like this session, let us know. Make sure you sign up for the next session, which will repeat some of these ideas, but show you a couple other principles around how do we make sure our code is sufficiently efficient to be able to solve problems at different scales, and talk about some of the other correspondences that we see between the approaches that we take in Python and how they fit into our rapid prototyping process. Thank you all for joining us. I know there were a couple of questions, but we'll try and answer those questions directly over email. With that said, thank you for joining us for the session. I know I had a lot of fun. My code mostly worked. It wasn't complete. Didn't solve every problem, but it mostly worked. And that's what matters, because now if you ask me, can you take the rest of the day to actually polish these up? I will say, yeah, and I'm almost certain that I'll be able to leave by 4:30 or 5. It's not going to take me 10 days. I have a set bound on the variance of the amount of time that it takes for me to solve this problem. And that's what is valuable in live coding and the rapid iteration and prototyping process.